This is the first part of the Chapter 9 lecture. This will be broken into 2 pieces, plus additional demos as necessary. Please take the time to go through the demos, as the demos will explore key functionality about JUnit. I'll talk about it as we approach them. The main concepts covered in this chapter are testing, debugging, test automation, and writing for maintainability. We've touched on bits and pieces of this in past lectures, but we'll continue to use our ability to go through this. Code snippet of the day is something to look at. What's the output that's produced here? This is an interesting bit of code, and it actually caught me off guard the first time I went through it. Take a moment. If you don't see what's wrong, pause the video and give it a longer look. Once you're ready, unpause it. Is the result 5, 6, 11, 2, double 12, double 4, double 22, double 66? The answer is double result 22. Okay? Why is that, you think? Take a look at the code again, see if your answer was right, and see why. There's one mistake and potentially one misunderstanding. Alright, here's the gotcha. After the for loop, somebody put a semicolon in there. What that does is it makes the sum plus 1 a separate code block. So if sum is equal to 1, this iterates through a bunch of times, and then sum equals sum plus 1 gets executed one time because this is now an independent code block, so sum is 2. So that's why you get the 2 here. Now if you remember way back when we talked about how Java handles strings and numbers, this was in one of the first lectures, because this starts with a string, it assumes everything is a string. Double result, string, string. So 2, 2 is what you get instead of the 4. Okay? If you don't believe me, put it into your Java compiler and try it. I actually did to verify results, and I was surprised because I actually missed that semicolon. Okay, we have to deal with errors. Errors are life. Early errors are usually syntax errors. Later errors are usually logic. What they mean by this is typically when you're coding, developers today like to just write code, see if it compiles, write code, see if it compiles, and just keep going through that until they get it right. So typically those are syntax errors. A compiler won't catch a logic error. Once you start actually doing the real testing, that's when you start to discover logic errors because a compiler can't figure that out. It's what people typically call a defect or a bug. Very true. You also start getting into a debate between is it a requirement or is it a defect? Or is it an enhancement? So enhancement, requirement, defect, you tell me, and oftentimes there's a little bit of a debate that goes on because very often in development shops, defects have to get fixed and enhancements are done at a later date. So the business tends to be pretty passionate about this one. Tread carefully, be mindful, and always think of the team as you're going through and debating it. Everybody simply wants to be successful. Some logical errors have no immediately obvious manifestation. Commercial software is rarely error-free. Defects get discovered. In some cases, defects get discovered years later. I remember working on one system way back that there was a defect that had been there for over 10 years and just simply never got caught. Prevention versus detection. You always hear, an ounce of prevention phrase, things like that. You can lessen the likelihood if you do good engineering, encapsulation, pay attention to cohesion and coupling, pay attention to your design, make sure that your implementation matches your design and that your design matches the requirements. You can improve the chances of detection if you use software engineering practices like modularization and good documentation. These things tend to cause issues to show up sooner than later. You can also develop good detection skills. Testing and debugging are 2 of the most crucial skills that you're ever going to need to. Testing your code, developers are classically known for being bad testers because they tend to test what they think of, and they tend to test the path that they call happy path because they know it works. Then when you run into an issue, what starts to separate the developers into groups is that your capability of doing debugging searches and finding source code mistakes. BlueJ actually has a pretty good tool for doing that. It's not the best debugger in the world, but it's a pretty good one. You can accomplish nearly everything you need to do right there. So, sometimes your defect is quite some distance from the source. So in other words, you might have a print statement 1,000 lines down, but the mistake happened in line 1 of the method. That's just how it is. And so oftentimes you have to look backwards and go up the code to try and figure out exactly where that problem is and why. Some useful techniques: unit testing using a concept called JUnit with BlueJ, and they also have some additional capabilities. Test automation, manual walkthroughs of your code, print statements, and debuggers. Unit testing. Each unit of an application may be tested. Method, class, and module are all the different levels that you test. Should be done during development. I always talk with my development staff that you test when it's on your device, and then you test again when it's checked into an integrated development environment. Just because it works for you doesn't mean it works with everyone else's code. And then from there, you get into QA, UAT, and other types of testing. As you develop your code, if you're using JUnit as an example, your test suite continues to build up and you get into even better capabilities. If you're using some stronger tool sets, you can do some amazing stuff. Again, BlueJ is pretty good. It has some really nice stuff in there. Understand what the unit should do. It's contract. In other words, the contract defines how it's supposed to work, what it's supposed to produce, and what the results should be. You need to do both positive and negative testing. What you don't want to do is only do positive testing, in other words, the successful outcomes. You also want to try and break test and do things that force negative results as well. You want to test your boundaries. A great example is people who put a field up on a screen, a little bit out of scope for this conversation, and it handles 5 characters. But if they type 5 capital W's, it goes off the side of the field and they can't see what they've typed anymore. Or if they type 5 small lowercase l's, it all fits pretty fine. And these are things that you want to check with your boundaries, just as one example. You want to check with 0 data, 1 row of data, and a full set of data. Developers classically test with only a couple rows that don't examine all the different types of data capabilities, and then they end up with disappointing results when it makes it into production. Further, you want to make sure that you have good diversity of data. If I have 1 million rows of Scott and I check, of course it's going to work well with 1 million rows of Scott, because from a data standpoint that's virtually nothing. It does nothing exceptional for me. Think about that and make sure that you've tested those different types of scenarios. Have diversity. All right, well-behaved objects. Main concepts to cover here would be unit testing, JUnit, regression testing, test cases, test classes, assertions, and fixtures. We're going to go through a couple more slides. I'm going to break and then we'll continue. Unit testing with BlueJ, within BlueJ. Objects of individual classes can be created, individual methods can be invoked, inspectors provide an up-to-date view of an object state, and we're going to go ahead and use Online Shop to do this type of work. I'll go ahead and record a separate demo for you, and you'll be able to see that. So at this point, I'm going to go ahead and do a break in the lecture, one, to go do that other demo if you want to see it, as well as it's a good logical division for this purpose.